competitions. In 2014, UNLV held our first 3MT, the Rebel Grad Slam, and this year is our 12th annual Research Rumble. The 3MT is a fantastic opportunity for students to learn how to convey who they are and what they study to an audience of folks who are mostly outside of their field. It's an opportunity to build public speaking and communication skills. It's worth noting that our slammers come from all over campus from a wide range of disciplines. This week, we have over 100 UNLV graduate and professional students assigned to compete in the preliminary rounds. Each will present their research in 3 minutes or less, using one slide and no props. We will introduce each student and then start the timer. If a student goes over 3 minutes, they will be eliminated from the competition. Now, let's turn our attention to the scoring for this Research Rumble. The judges will be assessing the competitors based on metrics, which total 24 possible points in 4 major areas: comprehension, content, engagement, and communication. Each judge will independently score each competitor. Judges will not penalize competitors for unanticipated disruptions that are beyond the slammer's control. At the end of the presentations, we will tally the judges' combined scores for each grad slammer and announce the winners right here live. The top 3 in this session will advance to the semifinals. So without further ado, let me introduce the judges, and then we will get on with our 3MT Research Rumble. We have a set of very distinguished judges in today's session. Judges, please feel free to turn your camera on briefly to wave hello as I introduce you. We have Dr. Willoughby from the College of Liberal Arts, Dr. Cashum from College of Hospitality, Dr. Inyat from College of Liberal Arts, Dr. Awan from the School of Public Health, Dr. John from the School of Medicine, and Dr. Wong Patagonpat from the College of Liberal Arts. Welcome and thank you for serving on our panel of judges today. We are ready to begin our competition. Our first presenter is Fernando. And I see Fernando on the screen. I will now turn it over to you. Thank you.
Going to your first dinner party is a lot like baking a new recipe without the recipe. You kind of have an idea of what it should look in the end, but you don't really know how you're going to get there with the ingredients at hand. To make things worse, everyone else seems to know exactly what they're doing, what to say, when to move to the next room, and how to use the different 25 forks on the table. Luckily, there's that awkward pause that everyone makes when you begin to make a mistake to keep you from really making a mistake. Hi, I'm Fernando Licea, and my research looks at how social behaviors unfold and how we can gain insights into how the brain is developing based on how those behavioral responses change from interaction to interaction. Meeting new people is a core component of being a social creature. And what's pretty cool is when you break down social interactions, you see trends being preserved across species, whether you're a human or a mouse. So what my lab wanted to do is take a known genetic factor that causes Rett syndrome and copy and paste it into the mouse's DNA. If DNA is like the recipe that your brain uses while it's developing, then MECP2 is like a helper gene that works with your DNA and helps decide how much of each ingredient gets expressed or added into the mix. So we wanted to see if initial social encounters of mice with this genetic mutation would somehow resemble what the social withdrawal we would expect to see in humans. And we were super excited when that was exactly what we found. Mice with this mutation in the MECP2 gene would be less likely to engage interactions, actively participate in the interactions, and maintain them once they've already begun. What we didn't expect to find was that our wild type mice would kind of pick up on when they were interacting with these mice with the mutation. And you could tell based on how they would react completely different, whether they were interacting with one or the other. Understanding the role that MECP2 plays in the brain circuitry of Rett syndrome is important because it helps us get one interaction closer to making sure everyone has a seat at the table. Thank you.
Thank you. We will now give the judges 60 seconds to score. Okay, we are now ready for Alex. Okay, I see you there, Alex. I will now turn it over to you. Thank you.
Thank you. Good morning, everyone. My name is Alex Blake, and I am a Master of Architecture candidate here at UNLV. My design thesis aims to serve the LGBTQ plus community through the lens of safety, connection, and identity expression. So my study is focused on the area called the Fruit Loop. It's the area centered around the intersection of Paradise Road and Naples Drive, and it's been the hub of gay nightlife in Las Vegas since the 1950s. So it's been recently designated as a historic landmark by the Nevada State Legislature earlier this year. And so my thesis is utilizing this momentum of this recognition to address different areas or different issues within the area, including pedestrian safety, the lack of community identifiers, and most importantly, the physical fragmentation within the district. So the built environment, it shapes the way we connect with one another or are isolated from one another. And in the case of the Fruit Loop, it does the latter. Paradise Roads, heavy vehicle traffic divides the Fruit Loop with 5 lanes of one-way traffic, and it creates dangerous conditions for pedestrians that are moving between venues. Um, a pedestrian fatality earlier this year resulted in the implementation of a proper crosswalk where there wasn't one prior. But despite this implementation, the presence of traffic and bar hopping patrons is a recipe for disaster, which is why I'm proposing a pedestrian bridge that will act as a catalyst for the unification of the district. So my research basically seeks to learn what aspects of a pedestrian bridge can reflect, protect, and bolster the LGBTQ plus community. So by abstracting the caste identity model as architectural elements, an elevated footbridge can connect the Fruit Loop both physically and metaphysically. So the investigation I'm undergoing for this thesis is rooted in grounding a psychosocial model of identity through architectural form. The Caste identity model was developed by psychologist Vivian Cass in 1979, and it's a framework for understanding the formation of homosexual identity. It's a developmental model with 6 sequential stages describing how individuals will recognize, accept, and ultimately integrate their sexual identity within their social contexts. So my research is using 3D modeling to abstract and interpret each stage of the CAST model. And then each iteration undergoes a visual analysis from critiques by professionals with disciplines ranging from architecture to urban planning, art to history, as well as community engagement through input from members of the queer community. So the goal of my research is to have it evolve into development strategies for the Fruit Loop, hoping to position it as a model for inclusive design. The most meaningful architectural work not only gives back to the community, but celebrates and strengthens it. Thank you.
Thank you. We will now hear music while we give the judges 60 seconds to tally up their scores. Okay, we're ready for our next slammer. Lena?
Hi everyone, my name is Linnea Bacon. I'm a doctoral student in the clinical psychology program here at UNLV. Today I'll be talking about research that I'm working on in the Optimum Performance Program and Sports Lab. Our research is focused on optimizing both sports performance and mental health in athletes. What do Simone Biles, Naomi Osaka, Tom Brady, and Caitlin Clark all have in common? Not only have they won at the highest level in their sports, but they've also been outspoken about mental health. Currently, up to 35% of athletes suffer from mental health problems. And we know that mental health issues can significantly impact an athlete's performance, increase their risk of injury, and even cause them to be unable to compete altogether. We saw this play out in the 2020 Olympics when Simone Biles, arguably the greatest gymnast of all time, had to pull out of her events due to performance-related mental health concerns. Unfortunately, less than half of athletes feel comfortable seeking support for mental health due to stigma and time demands. A recent study found college student athletes spend an average of 35 hours per week in athletic activities. That doesn't even include going to class, studying, working, or socializing. Student athletes have intense pressures on their schedules, their performance in their sport, and even sometimes carry the weight of being a public figure like some of the athletes on this slide. Because of these challenges, my research attempts to understand both how to support student athletes and implement psychological interventions that can improve their mental health and their performance. Right now, I'm analyzing a data set of over 3,000 college athletes to determine predictors of positive mental health. I'm also conducting a review of mental health interventions to determine what may help student athletes in their high pressure and demanding environments. However, this research needs to be able to be applied with real student athletes too. Because of this, I'm collaborating with UNLV sports psychologists to determine how we can best implement these findings into real-life clinical work. Part of this work will include collecting data here at UNLV to be able to track our student athletes' mental health, as well as the effectiveness of the interventions that we use with them. If successful, this research would provide insight into the daily experiences of student athletes while helping us to create programming that we can use with student athletes here at UNLV and beyond. If you've ever watched a sporting event or if you know a student athlete yourself, then this research impacts you. It's clear that when athletes feel better, they perform better. So next time you tune into a game, I challenge you to look beyond the scoreboard, see the person behind the uniform, and remember that their mental health matters just as much as their performance. Thank you.
Thank you. We will now give the judges 1 minute. Okay, we are ready for our next slammer, Melina.
Okay.
I will now turn it over to you. Thank you.
Hospital patient immobility is considered a preventable epidemic that remains frequent in routine hospital care, causing several harms, such as pressure injury, broad colds, and physical disabilities, reducing the quality of life of these patients and frequently requiring post-acute care on discharge. Physical therapy is part of the solution. However, the specific benefits of physical therapy and how often should be provided are still not very well studied. Thus, our purpose on this study was to evaluate the effects of physical therapy frequency on a hospital discharge disposition. How did we do that? This is an emulated clinical trial, and we used observational data from clinical and surgical patients to simulate hundreds of hospitalizations per thousand of patients. In our simulations, we included factors such as levels of mobility, functionality, number of physical therapy visits, and reward discharge rule. Then, we compared the effects of high-frequency physical therapy that defined as 6 to 7 sessions per week with conventional therapy, less than 5 sessions per week, on discharge location. What we found was surprising. We observed that patients receive daily physical therapy are 7% more likely to go home instead of going to post-acute care facility than patients receive less frequent physical therapy. When we look at the cost, the results are more evident. Providing daily physical therapy adds approximately $265 to the weekly cost compared to the standard 3 sessions of physical therapy per week. This investment is small compared to the average cost of a post-acute care facility that runs from $90,000 to $11,000. As a result, providing daily physical therapy has the potential to reduce the total cost of health from between $2,000 to $13,000 per patient, and while also can improve the likelihood of patient go home instead of going to post-acute care service. Thank you.
Thank you. We will now give our judges 60 seconds. We are ready for our next slammer, Shanika.
To start us off, I want you all to think about your first day of college. What was it like? Were you excited, stressed, maybe a little bit overwhelmed? Now imagine being the first person in your family to attend college. First generation students face all the usual challenges: grades, stressing about career decisions, and navigating new social networks. However, they also face additional systemic barriers, such as navigating hidden rules, finances, and differences in social and cultural capital. Hi, everyone. My name is Shanika Wickamarchi, and my research focuses on how first-generation students can be supported through mentorship. Mentoring has long been used to support students, but not all mentorship is equally effective. Some approaches can even unintentionally create stress or misunderstanding for students, leading to a relationship that's actually more harmful than helpful. For my thesis, I analyzed in-depth interviews with first-generation mentees, first-generation mentors, and continuing generation mentors in STEM mentoring relationships. From this data, I've learned what makes mentoring work best for first-generation students, particularly how mentors can support their students' confidence, success, and sense of belonging. Through my analysis, my team and I have identified 8 different themes that can support first-generation students. Here's what really stands out. 1, students really value a mentor who takes the time to teach, who are willing to teach them research skills, advocacy skills, academic skills, and professional skills. Students also value mentors who view them as a whole individual, viewing them holistically. This really helps to build that trust and support. And additionally, students value mentors who share their own social capital, which often leads to more doors, which often opens doors to more opportunities and networks. Now, to be honest, this has been a really nerve-wracking experience for me, but the reason why I'm sharing this with you all today is because I want you all to think about your own mentoring styles. Mentorship is a really powerful tool, but only when it is used intentionally and considering the student's unique experiences. Through creating culturally conscious mentoring relationships, we can really support first-generation students to not just survive in STEM, but to truly thrive. Thank you.
Thank you. We will now give our judges about a minute. Okay, we're ready for our next slammer. Neon Song, Harry?
Yes. Hello, everyone. My
I'm
name
just-
is. Oh,
Oh, Harry, I'm just waiting for your screen to come on. I hear you, but I don't see you. Okay, I will now turn it over to you, Harry. Thank you.
hello, everyone. My name is Harry Nian-Song Zhang. I'm the PhD student at College of Hospitality. I study how artificial intelligence can help tourism industry to make better and smarter business decisions. Today, I will show how I'm using machine learning to forecast air tour demand. It's something that have never been done before. If you have ever fly over the Grand Canyon in a small airplane or a helicopter, that's the air tour industry. It's big business. However, here's the problem. Most of the tour operators still estimate customer demand based on their experiences. So they may have too few aircrafts ready during busy weekends, or they have too many sitting idle when the weather turns bad. It hurts revenue and efficiency is low. So my question is simple. Can data predict when customers want to fly? To find out, I built a data set that combines flight operations, weather, temperature, holidays, and tourism patterns. And I developed machine learning models, basically those algorithms that learn from the data to predict air tour demand. The results are exciting. The best model predicted forecast almost 40% more accurately than the traditional method that I used. And it clearly identifies trends like the visibility, holidays, and time of week being the most significant predictors of the flight volume. So instead of guessing the demand, tour operators can now plan based on their staffing, based on the fuel orders and the flight schedule, all based on data-driven forecasts. And the results actually go beyond tourism. It shows how AI can help small and medium-sized tourism enterprises make better and more sustainable decisions, reducing waste, increase flight safety, and also support the local economy based on the number of visitors. In short, next time, if you fly with a date, if you take a scenic tour, my goal is to make sure that the plane is flying not with luck, but with data. Thank you.
Thank you. We will now give the judges 60 seconds to score. Okay, we're ready for our next slammer, Asal.
Today I'm going to share the story of my research, which is about water and effective distillation system. I'm a PhD student in mechanical engineering, and I want to say water is important, right? We can all agree on that. So what are the sources for water? It's lake, it's river, but there's another source which is more available and more abundant, which is like all around us. Water exists in the form of vapor and steam in the atmosphere around us, and it is everywhere. But is it possible to capture this water? Oh, yeah, it is. And we're doing that in our lab. Even in a very dry climate, like Las Vegas, we are doing it. So the way we are doing it is like if we have a very thirsty substance, such as like a salty material, salty solution, it will absorb water. It is so thirsty for water that it will absorb water into it. So what we are using is LIBR, and the system that we design is a capturing chamber which uses like hydrogel as a membrane, and there's an airflow under it. So, and on top of it is this thirsty, salty solution. So this membrane as hydrogen will let water through, but mostly nothing else can go through it. So we absorb water from the air through this hydrogel, and it goes through our salty solution. So now we captured water, but that's not the product that we want to use. We need to get this water out of this salty solution and have it as our product, as a liquid form. So we have this distillation system, and distillation sounds something that needs a lot of energy. So we are using heat source for this distillation, which is actually waste heat. So what I'm talking about is something similar to like data centers. So by the growing demand of AI, and there are lots of these data centers that they are producing a lot of heat and dumping into this environment. So the idea is to use that heat to boil this salty liquid, and it cannot be done unless it's under vacuum. So we capture humidity from the atmosphere, we use this waste heat source, and we get this water out of this salty solution as our final product. So what else, where else we can do this? We can use this system for desalination of seawater in order to produce drinking water. We can use it to manage sewage, like purifying water. We can use it for land disposals or any other salty solution that need to be managed. And as a heat source, there are a lot of heat waste that is produced in industrial processes, and we also can use like solar thermal sources. So this is like cheap and like very efficient heat source, and we are capturing water from the atmosphere around us. We are using waste heat, and we're producing water as our product.
Thank you. We will now give our judges 1 minute to score. Okay, we're ready for our next slammer. Taylor?
The crown jewels disappear from the Louvre. No alarms, no shattered glass, just a group of men in disguise and a perfectly timed plan. A near flawless heist executed in broad daylight. Now imagine the story unfolding not in Paris, but inside of you. You are the Louvre, your cells the crown jewels, your immune system the guards, and the clever thief? Shigella, a harmful bacteria that is silent, calculated, and executing the perfect regulatory heist right inside of your body. Hi, my name is Taylor Gerson, and I'm a PhD candidate in the Wing Lab where I study the pathogen Shigella, which infects the colon, causing a disease known as dysentery. Now, this disease is accompanied by symptoms such as bloody diarrhea, severe dehydration, and in some cases, death. Since 2020, the rise in antibiotic resistance has led to over half of Shigella infections being multi-drug resistant, prompting major public health warnings like that demonstrated in number 3. To combat this, my research focuses on understanding how Shigella controls the genes that it needs to infect the host in hopes of identifying new and novel drug targets to treat these infections. So let's picture Shigella as a group of microscopic thieves, where once inside the human body, a key protein called VIR-B acts as the criminal mastermind responsible for disarming these silent alarms. Or in our case, the silencing proteins that keep these harmful Shigella genes off. VIR-B, however, cannot function alone. It requires a passcode in order to disarm the system and turn these genes on, and this is where my work comes in. Displayed at number 4, my work demonstrates for the first time that VIR-B binds to a small molecule called CTP, as indicated by the appearance of a bullseye in the presence of hot CTP, and the subsequent disappearance of that bullseye in the presence of cold CTP. So with the help of the CTP passcode, VIR-B can disarm the system, turn these genes on, and let the rest of the Shigella crew spring into action, thus invading our host cells and bypassing the immune system like thieves running out of the museum with billions in crowned jewels. Now, this is not where my story ends. As indicated by number 5, if I make changes in VIR-B so that it can no longer interact with CTP, I can prevent VIR-B from ever turning these harmful genes on. So like the detectives that ultimately apprehended the Louvre thieves, I'm starting to piece together these molecular clues of how VIR-B and CTP collaborate to hijack the human body. In the future, if we can create drugs that block this interaction between VIR-B and CTP, we can stop Shigella before it launches its next regulatory heist. Thank you.
Thank you. We will now turn it over to the judges for 60 seconds. Okay, we're ready for our next slammer. Andre?
I was putting together a puzzle with my daughter. It came with 3 different pictures, each with a different number of pieces. We were just finishing one of them, and I finally placed the last piece. It fit perfectly. But then my daughter looked at it and said, "Dad, that piece doesn't belong there." The piece fit, but the picture didn't make sense. And that's exactly what is happening in medicine today when it comes to how we understand the blood vessels of adults with Down syndrome. For years, doctors believed that because people with Down syndrome tend to have lower blood pressure and fewer heart attacks, they were somehow protected from heart disease. It seemed to make sense. The piece fit the puzzle. But now, as people with Down syndrome have doubled their life expectancy due to medical innovation, the picture has changed. We are seeing more strokes, more vascular diseases, and higher rates of Alzheimer's disease. So the final picture doesn't match the old assumption. The piece was wrong. Why? Because almost everything we know about the cardiovascular system comes from studies on people with high blood pressure. But adults with Down syndrome are the opposite. They have low blood pressure, and we simply don't know if the same treatments or prevention strategies actually work for them. And that's where my research can make a difference. We developed a first of its kind protocol to study how arteries in adults with and without Down syndrome expand, relax, and stay flexible. We use ultrasound, the same safe technology used during pregnancy, to watch blood flow in real time. In one test, the traditional approach, a blood pressure cuff gently squeezes the arm to stop blood flow for a few moments. Then we look at how well the artery opens up again. But in another test, we introduce a brand new perspective. Participants simply squeeze a small hand grip device. This action creates a similar yet powerful vascular response in a more natural and comfortable way, especially suited for people with Down syndrome. By comparing these 2 methods, we hope to discover whether adults with Down syndrome show unique or even earlier patterns of vascular aging, because finding this missing piece could transform how we detect and prevent heart and brain diseases, helping people with Down syndrome live longer, healthier lives, and finally complete the puzzle with the right picture. Thank you very much.
Thank you. We will now give our judges 60 seconds. For our judges, I don't believe this last slammer is here. Let me just make sure. No. So judges, if you can put all ones in the form for this slammer, you could just enter all ones, and then when you are ready, please hit submit. Okay, so I want to thank you all for joining us for our preliminary rounds. Thank you to the Grad College who has made this 3MT event possible. Now, if you could just stay tuned, we are going to announce the winners live in just a few minutes. Judges, please be sure to press submit at the bottom of your scoring rubric form. While only the top 3 winners of this round will progress to the semifinals, you will all be winners of a Rebel Grad Slam t-shirt, and you can get yours during the Rebel Grad Slam Finals reception. I will give the judges just a few minutes to just hit submit, and then we will tally the scores, and I will be right back.
You are my sunlight. You are my sunlight. You are my sunlight. You are my sunlight.
Okay, welcome back, everyone. Thank you for waiting. Let me pull up here. Okay, so we are ready to announce our winners. As a reminder, for the preliminary rounds, our first place winner will receive a $300 scholarship. Our second place winner will receive a $200 scholarship, and our third place winner will receive a $100 scholarship. Are you ready? Here are the winners of this preliminary session. In third place, we have Shanika. In second place, we have Andre. And in first place, we have Taylor. Thank you again for your participation, and please join us for the semifinal rounds on Thursday, November 6th. They will be at 9 a.m., 11 a.m., and 1:30 in the Greenspun Auditorium. And the finals will be on Friday, November 7th at 4 p.m., also in the Greenspun Auditorium. Lastly, as a reminder, we will have your Rebel Grad Slam t-shirts available at the finals reception in the Greenspun lobby. We welcome you to RSVP for the finals event with the link in the chat, and there it is, ready for you. Congratulations to our session winners. I look forward to seeing you on Thursday. Thank you to all of our slammers for participating today. And of course, to our judges. Without you, we could not do this. Again, if you want to come to the finals and the reception, you can RSVP in the chat here. If you have any questions, you can hang on and we can help you with those. Have a great day. Thanks again. Bye.